Hey, it's Alex Williams with the News Stack here live from Palo Alto Networks studios in Santa Clara, California for a conversation about protecting the software supply chain. Joining me today for this conversation are Gareth Rushgrove of SNCC, Chenxi Wang. Hey, Chenxi.
Hello.
Chenxi is a board member and investor with Forbes contributor, a keynote speaker, a founder. She is now with Rain Capital as a general partner.
Yes.
And Rochelle Mattern, a developer with Google Cloud Platform. I know you work with Palo Alto Networks quite a bit. Excellent. So Gareth, my first question for you is, what about rugged software? What is rugged software? What does it mean today?
Oh, good question. I think rugged is that concept of like it. You can take it anywhere, you can beat it up, and it keeps running. So whether it's things that are just resilient to like the reality of running software. So I think the term comes up a lot in sort of operational circles, I guess. And there was the rugged security sort of side as well.
Thanks, Gareth. Chenxi, I want to ask you the same question. What is your view on rugged software? What does it mean today?
Well, rugged software has been around for a while, and largely it means a software that has a particular process that goes into development, so that it really could go anywhere. It could do anything. It doesn't follow very rigid software development practice, and it's really more sort of suitable for modern platforms such as cloud development or cloud native application development. So that's what the source of rugged came from. And today it means a lot of taking on sort of a new modern development practices like CI/CD, continuous development, all could be roped into the rugged umbrella.
Great. And so, Rochelle, when you think about it at Google Cloud Platform, how do you think about rugged software in the context of continuous development?
Yeah, so Chenxi mentioned, having a way to have software be able to be portable to any type of environment. And when I think about that, I think about Kubernetes. Kubernetes and containers are one mechanism that folks are going towards to make that happen. And the CI/CD process to release container-based software is also evolving. And one of the ways that we are at Google Cloud approaching, trying to kind of shift left, bring security into the CI/CD platform, is essentially building security into the release cycle and a deployment cycle of Kubernetes-based software. So essentially, like ensuring that each of the checkpoints that you go through as you release your software, include security checks, and then also to put checkpoints and metadata into your image to ensure that once you release it and deploy it, those checkpoints have actually been completed and passed, so that when you actually go to deploy, you can feel comfortable that your software is secure and that has passed the checks that your company has agreed are the security standards or the software standards that you have developed.
Excellent. Gareth, a follow-up question for you about the old ways of developing software and how that has changed and how we're seeing it today affect the people, the processes, and the technologies.
I think it's really sort of classically, it's that sort of developers built software, threw it over a wall, some operators had to run it. And honestly, in most cases there, the software wasn't rugged. Often, like it ran because operators were. The classic sysadmin of sort of of like just knowing far too much arcana about operating systems and saving the day with like sort of command line sort of voodoo. Realistically, trying to push that onto people just doesn't scale that well. So unexpected things happen in production. I think a lot of those problems are where the sort of DevOps movement came from and has sort of inspired all those conversations about how do we bridge that gap. I think part of that is then that software becoming moving some of that smarts from people into the software itself, and some of that is making that system as a whole more rugged, if you like.
Chenxi, I'd like to ask you that same question. So how do we see today's methods compared to the older practices? Because a lot of them are still in effect.
Yeah.
And how is this affecting the people, their processes, and how they're really developing software?
I think it's huge, the shift in software development practices, which in turn impacted software security go-to-market and software security offerings. So, I remember I was at Forrester back when secure development lifecycle, which was a big thing for the industry, and Microsoft was big on promoting that. So, but the whole SDLC concept was built for monolithic software development, right? So you write the design document, you do design review, you do threat modeling, all good things. Then you go into security requirement definition and you develop the software. Then you go into testing, and then you go into penetration testing, scanning, all that, which were sort of done in the end after the whole development process is done, right? And then you go back and say, oh, do we have any vulnerabilities? What do we do? And when you release software once or twice a year, you can do that. And in fact, a lot of companies operated that way. But today, we really see a more agile economy, right? It's pushing companies to release software faster, to update and build software faster. And I work with companies release anywhere from 50 to 200 updates a day to an application, right? Or to a set of applications. And when you are operating under this kind of business environment, you can't just do security at the end and as a gatekeeper function and then you clamp down, say you cannot release. That just doesn't work. It doesn't go with the pace of business. So today, this continuous development, continuous update culture has led to security becoming a more of a lightweight, more agile fashion that you can conceivably assimilate into your software development process. And I have seen lots of older, heavyweight software security mechanisms now shifting completely to the agile, to the lightweight, to the more sort of a sprinkle it in, but do it secure kind of way. And I, as a software security, as an application security person, I used to sit on the board for OWASP for 2 years, and we love that change because that means security is not just our responsibility, security is everybody's responsibility, including dev.
So what are those older practices that you still see at Google Cloud that speak of a time long ago, and how is that changing now? How do you see customers changing? How is it affecting continuous delivery practices? Those older methods that were a practice for rugged software.
Mm-hmm. Yeah, I think every customer and Google Cloud developer is at a different place. Some customers are still developing in a monolithic manner and are still using some of the methodologies that we have used for a long time. Other customers are already quite ahead in the journey, and they're full agile, full CI/CD, fully automated, and breaking things up into smaller chunks. And what we're trying to do is kind of meet the customer where they're at, and then help them, guide them towards moving and progressing towards the journey. Breaking down a monolithic app and then into something more, microservice oriented is not an easy journey. It takes time. It's a huge learning journey for all of the developers, all of the users, all the operations teams to kind of go along the journey. So we don't see everyone that is there yet, but I think it's starting to bring the practices of the more modern way of doing things into the older and meeting them where they're at, trying to make small improvements, and then as they can maybe split up their application, move towards containers, move towards some of the more modern ways to deploy software, start to build those in. So I think one of the things that we have tried to encourage our customers to do is automate, right? Because when you have to train a bunch of security engineers, a bunch of developers on all these new ways of doing things, it's very overwhelming. It's really overwhelming. And so if you can start to add components into the way you deploy software, or policy checks or enforcement mechanisms, there's a much smaller risk that you're going to release software with security issues or just even reliability or code issues in general.
So what are some of the initial things that you might recommend?
So some of the things that I initially would recommend are, one, try to figure out a way to implement a policy enforcer. If something gets released from an engineer who might not know that this is the company's policies, maybe they're new, maybe they haven't been educated, ensure that there's something that will remediate that right away. As I mentioned before, integrating security checks into your CI/CD so that you can even deploy if there is a security issue. One of the mechanisms that we have is some of the metadata that can get inserted as the GKE CI/CD process goes through, and then at the end do a binary authorization to check that each of these checks have been actually signed off. And then your software gets deployed. And if anything is not checked off, your software does not go to deployment. So any way that you can start to add these bits of automation into your deployment process will protect your company against potential issues down the line.
How about you, Chenxi?
Yeah.
What are some of the initial recommendations that you often see being made?
Right. So I think what she said, adding metadata, for instance, right, from source to production is a huge thing. In the old ways, what we have seen is developers just do their thing. They develop their software without thinking about security, and then they throw off over the wall to security teams that it's yours now. We move on to do something else. And security will do their testing without inside knowledge of the software. And they'll do all kinds of testing, and sometimes they'll come out with false positives like many, many weeks or even months later. Then they come back to the dev team and say, hey, look, we found. And dev teams already moved on. Some of them already moved on. Some of them will look at this as 60% false positive. I'm not going to pay attention to this, right? So there's a huge conflict, if you will. It's historically, it's a big thing in the application security space. Now what we've seen is the trend is, as Google is actually on the forefront of doing this, right? You push software testing and security testing closer to developers. And I think Google is one of the first companies that was doing unit testing, security unit testing by individual developers, as opposed to wait until application security folks take over, right? And when you do those tests before you check in, before integration testing, then you know you made this mistake, you can fix it, and you know the code. So you do a much better job. Now, early on, when I was with Twistlock, now is a Palo Alto company, we did this notion of source to production security. So what that means is we would scan your images, static images, but then our scanner is integrated with functionality on the server. Basically, the server would get notified whether this image has vulnerability, and that function will do a policy check and will make a decision whether you can deploy or not. And the knowledge is transferred from source to production. And I think that integration of pushing everything together, more integrated way, is exactly in line with modern DevOps.
Modern DevOps, yes.
Just to kind of add on to what she was saying, I think one of the things that I'm trying to push with any customer that I'm working with is that security is not just a SecOps team's job. It's the job of everybody. Yeah. And one of the ways that I think that is easiest to go about this is for there to be infrastructure as code templates, for example, because it's not just application security that we need to think about. It's also infrastructure security that we need to think about. So having templates that SecOps has reviewed, that DevOps has reviewed, that the developers have reviewed, that kind of can be used as little templates that you can kind of piece together and adjust for your specific use case. That's one way that you can kind of move quickly and also have confidence that the infrastructure is going to be built in a way that the company is going to view as most secure. Another thing is that I think security education is also something that I really try to encourage all of my customers to propagate it to all the developers, not just the SecOps team. Yeah. And have your developers know what your security policies are. Should you be using a private cluster on GKE? Are you okay with public endpoints? So ensure that your developers know what the company's perspective are on each of these different ways to deploy the infrastructure, and then when you can automate and check and ensure that there's checks in place that they are doing so, do that as well. So I think education and also to putting together any ways that you can automate checks that these policies are going through is important that everybody is a part of that.
Yeah, one more point,
yeah, sure.
If I may add. I think to have dev and security work more seamlessly together, we have to change the way the incentives are working in traditional software development environment. So to give you an example, I work with a company that the dev team's performance metric is about the rate of you bring code to market, right? So how fast you can push. And the security team, the success metrics is how many vulnerabilities you can find. There, fundamentally, there's a conflict, right? And so one is incentivized to slow things down so we can find more things. The other one's like, oh, my bonus is tied to how fast I can push the code. So, and this company actually went through a internal process to really change the way they incentivize performance on both sides so that they're much more aligned. And they also went through a practice of embedding security into each individual dev teams as opposed to a centralized entity, which they don't work really well with individual teams. So that structure change also made a big difference.
The structure change, indeed. Gareth, I have a question for you, and it comes back to dependencies and how they have changed so much and how so much is affected now by dependencies. The distance between the developer and the actual application is immense now. We see thousands of people actually maybe influencing how you develop your own application. We're talking about a new world of deep application systems. How do you view that?
It's not just the software we're running that's distributed. It's the whole system. It's the individual teams inside your organization, increasingly individual teams outside your organization. And some of them you might have a relationship with. Some of them you might not even know. They're writing open source libraries or open source systems that you're just being able to use. And it is, I guess, I think we're probably starting at least to talk more about systems holistically more than just software. It's a classic sort of socio-technical system. It's if you have software that's perfect, well, humans aren't, and combining humans as users, humans as operators, you've got a larger system. So I think there's all of those things going in part to make running software at scale difficult, and security is a facet of that. And I like to think of security as a facet of quality. And I guess overall quality hasn't been the thing we've always talked about in software.
Great. So I would like to turn this question back to you, Rochelle, about dependency and dependency management, because it gets into a lot of the real fundamentals of how you think about these new practices themselves. How are you approaching this at Google Cloud?
Yeah, I think, one of the challenges with all the different services that you can use with in the cloud space is that each one of them has their own dependencies or different, security approaches to them. And as I mentioned before, I think one of the ways to overcome this and also help the developers speed up is by creating these, templates via Terraform that are reusable, that developers can alter, but they're already kind of in a state where the dependencies are already kind of built in, or the configuration templates, or different things that you might use along the way. If you can kind of source some of these assets so that developers can start to reuse them, they don't have to think as much about, oh, I'm using this product, so XYZ dependency needs to be thought through. It's more like, okay, this template is built, these dependencies are already thought through, and will this work for what I'm trying to develop? And then alter from there. So I think starting with something that you can then build off of is really helpful in managing all of these different things and intricacies that you need to start to think about with all these different managed services coming to play.
You can also use utilities and tools. There are some open source ones that help you process your software, including the supply chain, to understand the visibility. I think GitHub has a Dependabot and a few other commercial solutions there as well. They will scan your images and help you figure out where the dependency lies, or if it depends on anything that has vulnerability in it, for instance, or license that not quite fit your policies, right? And those third-party functionality is good to have when you don't have a good way of managing your third-party dependency.
Yeah, I think that's a really good point. Like any way that you can automate and have extra checks in there, those tools are really, really valuable, especially as complexity increases.
Dependencies are also often viewed with the context of APIs. And APIs connect. Well, when they connect, what comes with it? What's the good, the bad, and the ugly that you're seeing out there?
Well, it's obviously offers something that's good. That's why people gravitate towards it, right? So I can develop my software as I see fit, and I can change things behind the scene, but as long as the APIs don't change, the applications that integrate with me can still function, which is a great thing, right? Target, I'll give you an example. Target used to, before they had APIs, in order to build a new application and get store locations into the application, just to get store locations takes 6 months. 6 months. And after they built, obviously, after they built APIs, instantaneous, right? I mean, the benefits are incredible. But the ugly part is it adds complexity when you have a ton of APIs, thousands, tens of thousands. Then you got to know what they're connecting to. Are they authenticated? Do they have the right parameter checks? And when you have APIs out there for like, I don't know, 10 years, do they still need to be out there? And are they still secure? It becomes a big complexity problem you have to manage.
So how do you manage that, Rochelle? Like, how do you manage the good, the bad, the ugly? What do you recommend? How do you think about this at Google Cloud?
Yeah, I mean, I think also too with APIs comes a lot of concern about letting go of control, right? I think with APIs, I think of a lot of managed services. I mean, obviously you can develop your own APIs and utilize those, but a lot of the managed services that folks are gravitating towards are also API-based managed services. And with those, you lose control of things like a static IP address that you can protect against. And I think a lot of security teams become increasingly concerned that, like, okay, a lot is going on behind the scenes that I don't have control over, or I don't have a specific, IP address to whitelist, or, all of these different traditional mechanisms of protecting go away. So there's a couple tools that we have developed recently for our managed services to help secure them better. So we have a context-based protection mechanism for API-based services that essentially allows you to pair different characteristics of the incoming traffic to essentially authorize access and authenticate access. So things like, is it both the user and IP that I'm expecting that the traffic is coming from? And those different context-aware mechanisms allow you to place multiple barriers to entry. Another thing that we have is We have a virtual service perimeter that you can put around managed services and APIs to essentially help with data exfiltration or ensuring that one service is not talking to another that shouldn't. And you can place that around groups of services. For example, if you want your GCS, which is your object storage bucket, to be able to talk to BigQuery, your data warehouse, but you don't want GCS to be able to talk to, for example, a compute engine. You can put a perimeter around those services that essentially will block the APIs from talking to one service for another. And so I think the combination of both starting to include these context-aware protection mechanisms as well as these virtual perimeters around services are some of the new ways that you can start to think about protecting your APIs and the services that are leveraging APIs.
So Gareth, what's the good, the bad, and the ugly that you're seeing out there with APIs? What's the state of APIs right now in your view?
Sort of, I guess, like APIs in terms of over a network have become that sort of classic way of scaling systems, whether it was talking about web services or now microservices, and whether it's HTTP or whether it's other interfaces. We've started to sort of externalize those APIs, but often internally. The advantage is you can have a sort of, I guess, the people consuming or sending information to that API can not care how you're doing things behind the scenes. They just care about the interface you're providing. And that's really simplifying. So I think from a good standpoint, that it's a way of scaling an organization. AWS is probably the classic example of that, and their sort of early mantra of no, teams interact via their APIs. The downside can be complexity of the whole. So maybe it's simple from the point of view of those two teams that are interacting around that API, but now you have hundreds of teams or thousands of teams and thousands of services, and the sort of what often gets described as the Death Star architecture, where individual services are talking to each other, but there's so much complexity moved into the network or the orchestration of those services that you haven't really simplified things. You've just moved that complexity around.
So Gareth, again, I have another question for you then. APIs do get outdated over time. How do you manage these older APIs? What happens to the credentials that access them? How are these issues being mitigated?
I think API evolution is, especially when it's basically trivial unless you have people using your API, and impossible if you do have people using it. The reality is you're often stuck with the assumptions you made early. And I think partly that's a good thing. And again, coming back to AWS is sort of an interesting example here, and maybe Kubernetes a more recent one. Mistakes in APIs which end up with widespread adoption are really difficult to change. But by not changing them, you end up with, from a consumer, having just knowing something is going to work. In previous generation, if you like, and of a sort of different type of system, the Windows API, and fundamentally by not changing the Windows API, that wasn't because smart people at Microsoft couldn't improve it. Some of them, I'm sure, were they're still pulling out their hair 20, 25 years later about mistakes they feel like they made in the definition of those APIs. But by keeping them the same, actually, they were able to have this guarantee of compatibility. And so you've got this interesting trade-off there of some of the most successful APIs, and maybe not beautiful, in a hindsight way, but they're the ones that are widely adopted. So I think there's a nice, interesting tension there. So sometimes the best thing to do with APIs is not change them. I think there it's about designing them so you can do it in you're never breaking backwards compatibility.
So APIs do get outdated over time. We see very old APIs out there. Mm-hmm. How do you mitigate that issue? Because if you change them, they break, right? You break the user then. Yeah. So how do you deal with that? How do you think about those credentials and how to access them over time, and how do you build that into the workflows, into the teams that are responsible for those APIs and for consuming them?
Yeah, I think I think there's three things that I would think about when it comes to managing APIs. One thing that I think is really important is version control on APIs. I think as you start to develop and update and these APIs, you need a good version control system so that you understand which API version am I on, and it's really easy to track which version you're on, and then also to associate metadata with those versions. This version includes XYZ update to the API and these changes, so that developers really easily know what they're going to get with the new version or what they're getting with the old version. So I think version control is really, really critical. The other thing that I think that we've been talking about all along is where you can start to break down your application. If you're only having to update one microservice of your application that's leveraging the API versus make a change to a larger chunk of code, that's a lot less intimidating to make these API changes that you might have to. It's a lot smaller risk. And the last thing I would say is kind of, in any way possible, doing some sort of asset inventory of what APIs are being utilized where, so that you know where your risk might be by having a 10-year-old API in place still. So those are some of the mechanisms that I would look at.
In fact, one of the most popular requests today for application security solutions is to audit and inventory my API endpoints. And people nowadays understand that API out there is a risk, right? And typically, people don't know how many APIs they have published because they've been writing software, they've been writing services for many years. And today, somebody said, hey, we need to audit all our APIs because we don't know who has the keys and what's out there. And that turns out to be a really, really popular demand today.
And that's critical, right?
Yeah.
And it gets into, I think, a segue into a conversation that I think is just emerging, and that's about open source software. And Gareth, I wanted to ask you this question really quickly because I think it's really important in that what we're seeing out there is that developers don't typically have security scanning software, and they're using, they're using third-party software, they're using open source programs, which really leads to a gap in an organization's security posture. It really affects how they operate. And so I'm curious about what are these gaps and how they're getting mitigated.
I think some of it is that open source is increasingly widely adopted. And that's definitely gone past the people who really think about open source. Open source, again, like 15, 20 years ago, was a bunch of people talking about licenses and understanding all of the bits and pieces. Now it's often that there is freely available software available in NPM or Maven Central or GitHub that you can use to accelerate your delivery. And so everyone takes advantage of that. And like that's success. The downside is that, and to a degree, you're getting something for free, but you're also what you're inheriting also has bugs. And some of those are going to be security issues. Some of them are going to be other types of issues. The upside here, and that was always true when you were using any third-party software. I would say we're probably using a lot more third-party software today, but probably more, we're using a lot more third-party software from a lot more people. And we don't know who those people are in lots of cases. So you're seeing attacks on that supply chain. And some of them are just accidental. They're hobby projects that you're using to run your business, and there are issues, and it's not because someone was trying to attack you or anyone else. But you are seeing attacks like people squatting in package managers with misspelt packages, trying to trick people into downloading something that has a backdoor in. You're seeing people sort of going after maintainers of particularly popular packages, or kindly offering to become a maintainer of a package that someone obviously doesn't want to maintain anymore in order to get access to not the source code, because the source code's freely available. They want access to the ability to publish a new version, bypass the source code process and have people automatically update to the new one. So there are lots of sort of, again, like classic supply chain attacks that are increasingly being applied to software. And this is no longer just about the high-end threat, I guess, which was always there with any software. And the Apple example being a classic example. That's not something that's you're going to go after on like trying to compromise the chips in the iPhone. That's a very high-end threat that most people don't need to worry about. I guess the wide diffuse nature of open source is bang for buck, someone compromising a high-end package gets you an awful lot of folks. And a lot of that's just about collecting and credentials to access other things. It's not about you as much as someone, say, grabbing your EC2 credentials and launching a bunch of Bitcoin mining, crypto mining, and shipping that off, or setting up spam relays. It's all about using you as an economic engine. And if you say, well, yeah, but they only got $1. Well, yeah, but they compromised 1 million people and got $1 million. Suddenly it scales in a way that you're just like, you feel hurt individually. It's not about you in lots of cases. If it is, you're in a more interesting place, and you need a lot more sort of security depth. But yeah, just the worldwide open source supply chain is, I think, like something we're thinking about more as an industry now.
So let me turn that question to you, Chenxi, about thinking about how you work with open source software and how you think about making sure that you're working in a safe manner, and how that affects a security strategy. What are some of the mitigating impacts that you really need to think about for your overall security strategy?
I think today, for anyone who's developing software, open source is a central strategy, right? Your developers are using them whether you are aware or not. And that's just a given. Now, the question then to the security leaders of the house is, how do you manage that? Saying no is obviously not the option. Bringing a functionality that helps you understand your supply chain, which open source software are being used, which images are being built into your developers' base images, for instance, is critical to understanding what your risks are. And once you know that, then you can start to manage the supply chain, right? So for instance, I know that I consistently pull down images for, I don't know, Red Hat or somebody else, CentOS. I need to know how quickly they issue updates and whether my developers are on the latest secure version versus they're using the old, could be vulnerable version, right? So knowing that as part of the software development process, knowing that when as software being progressing in the CI/CD pipeline and have that knowledge come in is critical.
Yeah, I'm curious from your point of view, Rochelle, about this issue of open source software. And I'm curious from your point of view, how does this affect the security professional out there, who has to really consider these issues?
Yeah, obviously Google is very pro open source software. We contribute back to tons and tons of open source software. However, I think one of the approaches, and I'm going to take this in the context of maybe like Kubernetes, for example, one of the things that I think security teams and teams in general need to start to think about is upgrade strategies, right? I think there's many instances where a team releases software and they are running on a certain Kubernetes version. And then the next Kubernetes version comes out and has a security patch or something, or some sort of enhancements that it has built into it. And the team is just like, well, my software is working on this version, I don't want to upgrade. And I think that's the wrong approach to take. I think, setting from the get-go, maybe after each major release, we will have 1 month to test, and then all clusters need to be upgraded to the next Kubernetes version. And then also to having a way to audit which clusters are now not compliant with my 1 month policy. And then, being able to alert the teams, and then even have a stronger mechanism of, I'm going to automatically upgrade your cluster within this, at the end of this month, if you do not go through testing and upgrade. Because there is risk if you're not upgrading, if you're not tracking, these changes to things like, security bugs or different things that the new releases take into account. So, set a really solid upgrade strategy, be able to audit those who are not complying with the upgrade strategy, and then be able to automate the upgrade if folks are not complying. So I think setting a really strong policy as far as upgrades go really helps to overcome some of the risk. And obviously there's a whole ton that come with how to secure different open source software, but I think upgrading is really critical, and people don't always think about that.
So for my last question, service mesh. It's a relatively new concept, but it really grows out of this complexity, doesn't it? Mm-hmm. What about service mesh in the security context?
Service mesh is becoming, one of those new buzzwords. I think a lot of companies, especially those who are more down the mature microservice route, are starting to think about service meshes, and Istio is becoming one of the at the forefront of the service mesh technology space. I think one of the great things that service meshes are bringing are the service-to-service communication and being able to secure the communication between these different services, and also like MTLS, like application encryption and things like that are coming with these technologies and making it a bit easier for folks to implement these security mechanisms for communication between microservices.
Yeah, so agree with a lot of things she said. One thing to me service mesh brings is this decoupling of data plane and control plane, which I think is really important in the modern complex networking, right? So what service mesh is, assuming that all the service endpoints have this data plane, a consistent data plane attached to it. What that means is this is entity that routes traffic in and out, handles data. And then you've got a separate, logically separate control plane, which is still essentially, is making policy decisions of who can talk to whom, and then instructs these different data plane to make the intended behavior happen. Right? Once you have these decoupling, then you can make the data plane extremely high performance and really network centric. Then you can make the control plane is really more sophisticated and more policy driven to have this God's view of what's going on and then make decisions. I think that in itself, this decoupling is really important for networking, for performance management purposes, but it's super, super important for security. Now that I can make decisions based on multi-endpoints, based on behavior that's not just local behavior, but global behavior, and I can dynamically change my policy because I'm not tied to the data plane. So that to me is a huge advantage for service mesh.
Thank you so much for joining us. Chenxi Wang of Ring Capital, Rochelle Mattern of Google Cloud Platform, and in Cambridge, England, Gareth Rushgrove of SNCC. Thank you very much for joining us today.
Thank you. Thank you.